My name is Umesh Salyan, and I work for Discover Financial Services. We will start with a brief introduction, basically to set the stage and context for the talk. Then, since it is about CSRF detection, I'm going to use a test application to show CSRF in action. And then we'll use an open source product to scan the application and see how it performs in detecting the vulnerability. And we will analyze the results. I might say that results are not that great. And then finally, we will look into a small piece of code that I wrote. And we'll try to scan using that and see how that performs in detecting the vulnerability. Okay, so this work kind of started about 2 years ago when Discover as a company, we decided to move towards CI/CD process. So like every other company, we wanted to have a CI/CD pipeline built so that we have products delivered to production more frequently. But being a financial company, the obvious question is, what about application security? The fact that you're releasing the code in much higher frequency means that there's more chance for vulnerabilities to creep into production. So we need better process to basically monitor and address application security vulnerabilities. So obviously the standard answer is shift left. So that's what this slide shows. But at that time, we really didn't have much in terms of having stuff on the left. We didn't have much. We did have some static analysis process going on, but besides that, there was not much else. We wanted to be in a state like this where we had some kind of testing going on at each phase of the application life cycle. I mean, we did have. So we did have a pretty mature pen testing program. That is something that was worth talking about. But other than that, all we had was a little bit of static analysis. So I was given the task to basically build a dashed program to set up a dynamic application testing program and integrate with our CI/CD pipeline and automate the process. So we wanted this automation done, and that was the task given to me. But when I started, I really did not have any knowledge or experience in this field. So I did not know, how to go about it. So what we decided was basically to start small, play with this stuff and gain experience and gradually take it to maturity. So we didn't want to try directly with a commercial product. So we decided that we should be playing with open source products to begin with, gain experience and then go from there. So two products were brought to our attention. One is Arachne, another is OWASP Zap. Just out of curiosity, how many of you here use Arachne? Show of hands. Not many. That's interesting. Okay. Okay. So our idea was that we should really place and see which of them basically lends itself well for integration with the pipeline and that kind of stuff. So, but in order to play that, we have to have an application, and I didn't want to go and use one of the enterprise applications because they can be pretty complex with a lot of dependencies, and it may be difficult to play around with that. So what I decided was basically to build a small test application and try out these products and see where we feel comfortable using and go from there. I'm actually going to show the application because I'm going to use it heavily for the rest of my talk. So what I have is I have here virtual Ubuntu in VirtualBox, and my application is running here. So let me quickly show how it looks like. Well, it's a big bank application. You will immediately get to see my front-end programming skills, fantastic skills, but please bear with me. Basically, this tries to mimic a typical e-commerce website, right? That's the idea. So, like any other e-commerce web application, you basically log in using user ID and password. So let me go ahead and do that. And then it brings you to an account summary page. And then there is this personal profile where it kind of shows the user's user ID, the address, phone number, and email address. And I have this link here. And if I click that, it takes me to this form where if I want, I can change my profile. And so, yeah, I mean, it's simple. I just change one of them. It changes fine. But what I wanted to show here is that there is some kind of input validation, right? So let's say by mistake I type like that, make a mistake, and try that. It doesn't accept it. It says, okay, invalid input, you got to correct it. And like every typical application, it basically puts the information back to help the user. And that means this form is basically susceptible to reflected cross-site scripting. Okay, fine. I can actually, okay, let's prove that because I'm going to scan it later. So I'm going to use an input which has inline JavaScript in it, which will basically pop up an alert. So, okay, let me go ahead and put this and really confirm for myself that this does have cross-site scripting vulnerability. Okay, when I put that, there goes the alert, right? So we convince ourselves that this form, the page is not polished, it doesn't look good and all that. That's fine. An attacker would really do a good job on that, but my intent is just to show here that this has cross-site scripting vulnerability. Okay, and this form also has CSRF vulnerability. So to prove that, what I'm going to do is, usually you get a very fancy email saying that there is some nice thing going on, you got to sign up for that and all that. So something of that kind. When you have a hard deal and it's not public yet, you want to be the first one to sign up, so probably the first thing you would do is go and click, right? So let me keep this here and let's see what happens. So when I go and click here, well, you notice something? Now see the address here and see the address, the information here. Information is changed. Now if I go back here, just to confirm, the personal profile information has changed. And why did that happen? That's because the link that I showed, this one has a hidden CSRF form in it. Like if I view the source on this, there is a hidden form, and when I click the link, the form is submitted, and the form has the information to change the details on the page. So this is how standard CSRF works, I guess. If you have a single page submission, then that's a classic case where you can have CSRF going. Okay, so what this shows is that this page is vulnerable to, this form is vulnerable to both reflected cross-site scripting and CSRF. Okay, that's good. Okay, fine. Now what we will do is I'm going to scan this application using a scanner. I'm going to use Arachne to see what it finds. All right. So okay, I have a small script here, which for Arachne you can use in command line, and you'll have to give a bunch of information like what is the URL, what's the user ID, password to log in, what's the target URL you want to scan, and what are the vulnerabilities that you would like to scan for. So I need to provide that information. Let me quickly make sure that I have the right information. 1 second. Okay, so the last line here tells the scanner what vulnerabilities it should scan for. So what I'm saying here is that it should scan for X-frame options, header in the JSP pages and also for cross-site scripting. I included XFrame options deliberately because we will find something about it when we scan. But at this point, I'm not scanning for CSRF. Okay, let's go ahead and run the scan. It will only take about half a minute. I keep this to make sure that it's hitting my application. Okay. Okay, the scan is finished, and here it says it scanned 4 pages, and here are the results. And it identified 7 high severity vulnerabilities, and it found 1 low severity vulnerabilities. Okay, so let's see what those vulnerabilities are. They are okay. So it's put in here. This is the report it generates, and if I open it up, this kind of shows some pie chart. That's fine. But if I go here, it kind of shows all the details of the vulnerabilities. So it says that it has found 7 high severity cross-site scripting vulnerabilities. And one of them is associated with the cookie, that's okay, but other than that, it has found 6 vulnerabilities within the form. And if you go back to the page, those are these 6 text field elements. None of these text field elements have protection against cross-site scripting, and that's what the tool is showing. And and if you go down, it also shows XFrame options. So that's a low severity vulnerability. Okay, that's good. It's kind of nice. It has detected the cross-site XSS vulnerability. All right, what I'm going to do next is that now I want to see how the tool performs against CSRF. All right, so I'm going to edit this, and instead of scanning for cross-site scripting, okay, so all right, now it's going to scan for CSRF vulnerability. Okay, it's finished. And it scanned 3 pages, and there are no issues, right? But we did see earlier that the form has, and that's the reason why I demonstrated that this form does have CSRF vulnerability. But Arachne is not able to find it. That kind of puts a bit of suspicion in my mind. Why did this happen? Is it, okay, it's not able to find CSRF. So is it really doing a good job about cross-site scripting? Now, one way to find that out is basically put a remedy to the cross-site scripting that we have and see what comes out. And let's say it just, just the way it's not able to find it, maybe it's found something, and even if you remedy it, maybe it'll still show up. I don't know. If it doesn't show up, then I can kind of say that, okay, I can trust this product for identifying cross-site scripting. Okay, so let's do that. So what I have here, okay, let me close this. What I have is a page where I can control the vulnerability within the application. So I have the fixes for those 2 vulnerabilities within the application, but it's just that I have not enabled it. I mean, I have the screen where I can enable or disable at runtime. Right now, they are all disabled. So what I'm going to do is that I'm going to enable output encoding on my form input. And also, I'm going to enable setting XFrame options header in my response. Okay, let me submit that. Now, I want to really verify that that is indeed taken care of the vulnerability. So what I will do now is that, let me pull the page again. Okay, there it is. And let me put the same piece of input that I gave earlier. Okay. And you see this time we didn't get the alert. And if you look in the text field, what you notice is that it's displaying the exact input that I provided. So when it came back from the server, since the data is encoded, it didn't give a chance. I mean, the browser doesn't get to interpret the data, so there's no mix-up of the data with the interpreter. So it was displayed as is. So this basically remedied the vulnerability that we had. Okay, so this does show that the fix has worked. Now let's go and scan and see what happens. So if the tool is good, then we should not see any issues. There it is. It scanned 3 pages and no issues. So what this tells us is that Arachne is actually good in identifying cross-site scripting vulnerability. It does a positive identification of cross-site scripting, but it fails to identify CSRF. Then my next question was, okay, that's the problem with this tool, but what if I use some other tool? I'm not going to show it here. It takes some time. Let's not lose time on that. But just to state the results, when I ran the same exact test using ZAP, I got identical results. Again, ZAP was able to correctly identify or positively identify cross-site scripting, whereas it failed once again to detect CSRF. Now, the nature of the failure was different. What we saw with Arachne is that Arachne gave us a false negative. It did not show the CSRF vulnerability, even though the application had the vulnerability. Whereas ZAP did the other way. What it did was it gave a false positive. That is, when there was vulnerability, it did identify the vulnerability. But when I put the fix on that, it did not show that there is no vulnerability. It continued to show that the application had CSRF vulnerability. So the two products had two opposite problems. And I actually happened to get a commercial product too later. And when I tried the same test with that commercial product, once again I got this very similar results. So all the 3 products were not able to detect CSRF vulnerability properly. So this kind of made me think, what's going on? I mean, is there a reason why this is happening? And I thought about it. What occurred to me, in fact, I did write to Simon Bennett, who is the project lead on ZAP, OWASP ZAP, and he did send me the code which identifies which is used to identify the CSRF token in ZAP. So then it occurred to me that, it's kind of not easy for a tool to identify the CSRF token. And the reason is the following. Okay. Okay, now let's think for a moment how a tool might want to do this, right? I mean, you have your application and you got this tool from somewhere and you are running the tool against your application and it has to identify the CSRF token. Now, we all know that CSRF token is just a hidden field within your form and it's populated and things like that. So the tool has to identify that. But the problem is, your form may have a number of hidden variables. It's your business logic. You may need multiple hidden variables within your form. So let's think of a situation where there are 10 hidden variables within your form. Okay? And then next thing that is possible is that out of those 10 hidden variables, you may have a token CSRF, anti-CSRF token, or you may not have. You do not know. Both are possible. Okay, the third thing that comes to your mind then is that this CSRF token may have any name. Somebody may choose to use the name CID. Somebody may say CSRF token, CSRF token, CSRF underscore token, secure ID, random key. You can come up with the name you want, because all you need is a hidden variable on the form, and you need to capture on the server side and validate it, right? You can name the way you like. So when you put them all together, now let's think for a moment how the tool should identify CSRF token out of all this. Is it even possible? It's just not possible, right? I mean, the tool has to make some assumption about this anti-CSRF token. Maybe they assume that the name of the token is CSRF. Okay, I mean, it may find a hidden variable, but if there are many hidden variables, which of them is the CSRF token, right? That is the problem. It is not possible, it may not be possible to correctly identify the token. So we come to a conclusion, and that is a tool can never reliably detect anti-CSRF token, of a form on its own, right? If it has to detect on its own with whatever assumption that it has made, maybe it will detect, maybe not. There is just a chance, right? You can never be sure that the product will identify the token. And that's what exactly was happening with all those 3 products that I tried. I mean, they have made some assumptions, somehow that didn't match with what I had in my form, and they either didn't detect or they continued to say that, you know, you have the issue, one of those. So if you turn around the same argument, what we are saying is that it requires an agreement between the application and the scanner for positive identification of the token. So there has to be an agreement between your application and the scanner on the name of the CSRF token if you want a positive identification of the CSRF token. Otherwise, it's just a chance. Okay, that's the conclusion. Okay, now let's say, okay, somehow we take care of that. Let's say we do have an agreement. I mean, one way you could do is that you could go find out what the scanner is looking for and find out that name and make sure all your forms have the same name. You make sure that you change your application so that you have the same name on every form that you have. Or you could, what you could do is you could have the scanner a configuration where you basically provide the name of your CSRF token, then it can look. Either way, there has to be some way of understanding between the two for the identification. Now, let's say we change our application so that we let the scanner exactly the name of the token, then will it work? Does that make it a reliable CSRF vulnerability scanner? So that's the next question. We have taken care of the fact that now the scanner is able to identify the token. But it turns out even if you do that, you cannot say that your scanner will be good. And the reason is that just having a token on the form is not sufficient for it's not sufficient for your application to defend itself against CSRF vulnerability. Why? Because what is required is that this token must be validated on the server side. What's the point if you just have a token and it's not validated on the server side? That's the idea, right? You should validate on the server side so that you don't have it form that comes in without a token that is sent by the server. So unless you take care of this condition too, a scanner is no good. Okay, so let's think about it for a minute. We want to do this. Now we want to do a better job on our scanner. We want to the scanner to identify CSRF token. It has to make sure that there is a server-side validation as well. Now, this turns out to be a pretty hard problem because if you think about it, you have your application again on one side and you have your scanner on the other side. The scanner has no knowledge of what's going on the server side. It can only send some requests and get the responses back. And based on this request and response, it has to determine that you have server-side validation or not. I mean, the application side code is not coded to basically tell back that there is server-side validation, right? If there is validation, if it is good, it will keep going and it will show some page, you know, something that serves the page. There is nothing that indicate that you have server-side validation. But here is a thought. Let's assume for a moment that we do have server-side validation, right? And then, okay, you get the page from the server, and then you submit it. So since it has the token that came from the server, it will be validated and it will go to some page. That's fine. We can't do anything about it because we don't know what page to expect. But let's think of the situation where there is no valid token on the form. So if you submit a form that doesn't have the valid token, then what will happen? Then the validation will fail on the server side, which means the response that comes back is not what it would be if the validation was successful. So there is a difference. So there is a difference in the response if the validation was successful and if it is different. So we can probably use this fact to say that, okay, do a test like this. First, make a call with the valid token in the form, make note of the response, and make another call where you have deliberately altered the token and submit the form. Now the response is going to be different. Now the response is going to be different only if you have server-side validation. If there is no server-side validation, altering the token doesn't make a difference, so the two responses should be the same. So you can make use of this argument to say that, okay, I have now found a way to identify when there is server-side validation. It seems like a good logic to start with, but unfortunately, even this will not work. And the reason is the following. Now think of the situation where, let's take the situation where we do have server-side validation, right, once again. Okay, let's take the scenario where the call is basically money transfer from your bank, let's say. Right, and let's assume that your bank has a balance of $150. Now you make the call where you request a money transfer of $100. So the first call will go through because you have transferred $100 out of $150. That works fine. But when you make the second call, that call is going to fail. Why? Because you do not have sufficient balance. Now the second response is going to be different because, not because of CSRF validation, but because of a business logic. It's for a different reason. So you cannot rule out this possibility, right? So that logic is not going to work. The problem here is that the tool is trying to infer about CSRF validation error based on the response, and that response is a mix-up of validation, CSRF token validation, and business logic. And there is no way the tool can distinguish between the two responses. And that's the reason why this will fail. So if that is the case, we make one more conclusion, and that is a tool can never reliably detect on its own if there is server-side validation of the token or not. It can never do that on its own. If you try this, it may work sometimes, but you can never reliably say that, yes, there is server-side validation or there is not. You can never conclusively say that. And therefore, once again, it requires an agreement between application and the scanner on the exact error response on server-side validation of the on server-side validation failure. So, in other words, if your tool needs to detect if there is server-side token validation, then the tool should know exactly what error response comes back when validation fails. And that error response should not be mixed up with any application logic. Like that error response should never be used for any other error scenario within your application, like I don't know, either business logic failure or some system going down, or you're not able to make some service call or anything of that kind. Oh, okay, that's interesting. All right, so with that, what we have here is a small piece of code that will make use of these two conclusions and try to come up with an approach that tries to do better on CSRF vulnerability detection. Okay, so here is that piece of code. It's pretty small. It's just about 100 lines, but it has comments in it. So really, it's only 50 lines of code. And this uses a web tester, a headless browser from SourceForge .NET. It makes a couple of calls. I'm not going through the details of that, but it checks a couple of things. You basically set it up for logging in with username and password, and then it checks whether you have the token in the form, whether token has value, and whether server-side validation is happening or not. But for this to work, it needs two crucial pieces of information, and that is these two. The first one is the exact ID of the CSRF token on your form. It is required. And the second one is the exact error response that the application is sending back when the CSRF validation fails. Now, one thing I want to mention here is that the error response says CSRF token validation error. This is something that we should not be doing in our application that goes to production, because you do not ever want to give the bad guys why a certain request did not go through, right? We always want to give a very generic error message saying like technical difficulties. Sorry, we are unable to process your request because of technical difficulties. We do not want to say why and what, because that would be like giving the information to the bad guys to basically improve their attempts. I have shown it just for clarity, but if somebody wants to implement it, somebody should come up with more creative ways, like put some numbers that you identify and throw around some random numbers so that one cannot generate a pattern, something like that. Anyway, okay, so that's the code. What I'm going to do now is I'm going to use this to see how it performs against the vulnerability that we have with our application. Okay, so let's see. Let me go back here. Okay. So at this point, this is the situation. So I do not have anti-CSRF token on my form. I mean, I can show the page shows, but we are not going to go through that. But let's assume that it is not there, and let's scan it. And so, okay, so I'm running my test code against my application now. It's done, and this is the result. So this is like a JUnit test, if you like, but it runs against a deployed application, and it has the methods, and my test failed. And why did it fail? It gives the exact reason here: no anti-CSRF token in the form. It tells me exactly why my test failed. Oh, okay, that's good. If that's the case, I can go and add my token. So I'm going to add the token, and if I can confirm that now. If I pull the page again, if I view the source, there it is. I have my hidden variable here. It's called a CSRF token, as it is expected in my test code. But you see, it doesn't have a value. It's empty. It's a situation where your front-end coder is different than your back-end coder. Front-end developer has put the variable, but the developer at the back-end didn't or forgot to populate that, or something of that kind. That's the situation here. All right, let's go and run our test again. Let's see what happens. Okay, it failed again, but this time the error message is anti-CSRF token has no value. Once again giving the exact information, saying that okay, you have the token fine, but it is not populated. Okay, it doesn't even go further, because you don't need to go further. What's the point in having just an empty token and submitting it, right? It failed even before that. Okay, let's go a step further. Now, oops. Oh. Okay, let me go ahead and populate it this time. It's going to be populated from the server side. All right, let's pull the page again, see how it looks like. And if I view the source, you see now the token is populated. Okay, but I mean I cannot show it to you, but it's not being validated on the server side yet, right? It's just populated. There's no validation going on. Okay, let's run the scan again. Again, it failed, and this time the error message is no anti-CSRF token mismatch error response on whatever, some weird message. Of course, it's mine, I put it, you can change it the way you want, but here is the possible cause. Server-side validation is not enabled. Once again, you get the exact information. Now you have the token, it has a value, but it is not being validated on the server side. It gives you the exact information why your CSRF defense is not working. Okay, let's go a step further. This time, let's even enable server-side validation on the token. Now we have the full defense. You have the token, you have it has value, and it is being validated on the server side. Right? All right. Once again, I cannot show it using the form, but I can run the test. There it is. This time the test was successful. So the scanner now says that, okay, you have a valid CSRF defense. Now the application is safe from CSRF attacks. Yeah, so that's about the scanner. I mean, it not only tells you what the okay. Let's go back to the slide. Let's discuss it there. But there is one important thing that should be observed, and that is, in your application, you may have many validations. Like if you think about it, you have first authentication or authorization, then you probably have form validation, and then you also want to have anti-CSRF token validation. Now, one of the things that should be done first before form validation or any other validation is that one must take care of the CSRF token validation first. And the reason is that if you don't do that, it's possible that you will send a different error message back, because let's say the form validation fails and you send the error response corresponding to that. Then the scanner does not get a chance to verify whether there is CSRF server-side validation or not. And that's the reason why it is important to send this error response before you do any other validation or business logic on the server side. So what we see is that this code, which is just about 50 lines, is simple, it's reliable, and it's efficient. It's very easy to use. So these are some of the advantages of that. And I think the key, the best feature of this is that it reports the cause of CSRF vulnerability exactly, right? Like you may have a tool, it may detect it, but at the end what it will say, okay, you have a vulnerability on this form. Then you have to go figure out why is it. Is it because you don't have the token, or is it because it is not being populated, or is it really because it is not being validated on the server side? Whereas in our case, what we see is that it tells you exactly where it failed, and that way it allows you to troubleshoot or fix the issue very quickly. The next advantage is that it enforces standards for CSRF defense. The fact that the scanner needs to know what token you are using. So if you don't use that token, even if you have some other token name for the token, it's going to complain saying that, okay, I didn't find the token because you asked me to look for this token, I didn't find it. So it will force you to change your CSRF token name to whatever it is looking for, and that's a good thing. You want that kind of standardization across your application, right? You want to use one set of names and validation method for every form. You do not want the token to be named something in one page and a different name in another page. Although it is possible locally, it works fine, but it's good to have this standardization where every form has the same name when it comes to a CSRF token. And the same thing applies for your validation error response as well. It will basically force you to have the same error response sent back. Otherwise, every time you do the scan, it will say, sorry, you don't have server-side validation. So it will basically force you to use the same error response every time. So that's a good thing about that. And the next thing is, as you saw, it is just a small 50 lines of code. And you can easily build a test suite, right? Suite. You can build a suite. Once you have it working, what you can do is you can go on adding these for all the forms that you have in your application and build a test suite. And it becomes really easy to run them all in once. So once you deploy your application, just fire it once, put them all together, and build a suite. And in one sweep, it will scan the entire application, and it will report a vulnerability anywhere in your application if you include all the forms in your suite. And that's a good thing, because we all want to automate our security testing as well these days. So when you can build a test suite like that, now you can easily put it in your pipeline and have it test through your pipeline, and it makes it very easy for you to do this. Whereas any of those tools that you think of, it's not always easy to automate the testing the way you can do it with this one. So that's all I had to share with you. If anybody is interested, I have the code checked in GitHub. You can take it and use it. Thank you for listening.